One way to solve the problem in the last video is to use an array of objects here, because the object class is the base or the parent of all reference types in Java. Remember reference types? We talked about them in the first part of this series. To refresh your memory, we have two categories of types in Java: primitive types and reference types. Primitive types are numbers, characters, and booleans. Everything else is a reference type. So if we use an array of objects here, we can store anything in this array. For example, we can store user objects because the user class extends the object class. So let's replace all these integers with the object class. So here we have an object array, and here as well. The parameter of the add method should be an object. And also, the return type of the get method should be an object. Now, back to our main class. We can store numbers in this array. We can also store strings. We can also store user objects. So that's great, isn't it? Not really. This is a very bad solution for a couple of reasons. But before we talk about these reasons, I got a question for you. Earlier, I told you that the object class is the parent of all reference types, so we can store any objects in this list. However, this integer here, this is a primitive value. It's not an object. It's not a reference type. So how can we store it here? Well, when we compile this code, the Java compiler will convert this code to something like this: integer dot value of 1. So we have this integer class in Java. It's a reference type. It derives from the object class. And this class has a static method, value of, which returns a new instance of the integer class. So this is the reason why we can pass a primitive value to this method. By the same token, we have a wrapper class for every primitive type in Java. We have float, we have double, boolean, character, and so on. Okay, so let's revert this back. What are the problems with this implementation? Well, the first problem is that if you want to get the first item in this list, we call the get method. Now, we know that this is an integer, so we may hope to store it in an integer variable called number. But we have a compilation error because this get method returns an object, but we expect an integer. So here we have to explicitly cast the result to an integer. And this makes our code a little bit verbose and noisy. The second problem is that if we use the wrong type here, we'll get an invalid cast exception. For example, let's change 0 to 1. We know that the second item in this list is a string. What if we accidentally try to cast it to an integer? We run our program. We get a class cast exception. Now, the problem here is that we will not be aware of bugs like this until we run our application and test all the functions. So we can only identify these problems at runtime. It would be great if we could catch these problems at compile time. And that's what generics are for. In the next video, I will show you how generic classes help us solve these problems.